Now the tough one. Set notation. This is probably the least familiar way of representing domain and range, but it is the most popular in pre-calculus, and I think it's the most descriptive way of explaining domain and range. I guess when you use words, you have a pretty specific sentence about what the domain and range are. But set notation does it in a very condensed and detailed form. I want you to use these set brackets that I used last time, right? You remember what those meant, just a group of numbers. I want you to just take a second and see if you can list all the real numbers between 0 and 20, our domain here, right? T. All the real numbers between 0 and 20. Pause the video, give that a try. Okay, we're back. Did you find it difficult? If not, maybe you don't know what you're doing. But I'm going to try and attempt it. Okay? All the possible real values between 0 and 20. Let's get started. Well, we've got 0, and we've got 0.2, and 0.3, 0.5. Oh, hold on, I missed some numbers in between here. There's some numbers in between 0 and 0.2. There's also maybe 0.01 and 0.001 and oh man, 0.0001, and I guess there's numbers in between 0 and 0.001 that I forgot to list as well. There's 0.00001 and 0.000000392. Missed some numbers again. More values in between 0 and 0.00001. You see the problem, right? I haven't even gotten to 1 yet, right? I haven't even listed 1 because there's still numbers in between these two. I know this may seem like a little bit of a shock to you, but there are actually an infinite number of numbers between 0 and 1. And you might think, how can that be? Because you have like a starting point and an ending point between 0 and 1, right? You start at 0 and you get to 1, and so that's like a finite distance. There's got to be some kind of limit to the number of numbers between 0 and 1. But actually, you could just go on forever. You could just keep making smaller numbers in between those two, and you would have an infinite list of numbers. So you may be scratching your head at this point and wondering, how do you write a set? How do you list an infinite number of numbers? How do I write all the possible numbers between 0 and 20? Is it even feasible? Is it even doable? The answer to that, of course, is no. But there is a way to represent it mathematically. There are 3 parts to this set notation that you use for continuous data. Right? When we had discrete data, it was pretty simple. We just wrote the numbers that were there. But with continuous data, we can't do that because we've got, technically, an infinite number of values. So here's what we do when we have a continuous set that we're trying to define. The first thing that we write is the variable, okay, that represents that independent variable. In this case, t. T is the value that represents our domain. Then you write this this vertical bar. In math, this vertical bar means such that, which might sound weird right now, but I'll explain why it means that in a second. Okay? After that, we write restrictions on t, meaning if it has like a lower bound and an upper bound, we say what those are with an inequality. So t has to be bigger than or equal to 0. You'll remember with inequalities, this alligator mouth eats the bigger value. So we want t to be bigger than, but I also wanted to include 0, so I put the line underneath. So I want it to be bigger than or equal to 0. At the same time, I want it to be less than what number? 20. Right? I want it to be less than or equal to 20. Okay? These are called the restrictions on t. Restrictions on t, and this is just the variable in question. Okay? The last thing we need to say is what kind of numbers t represents, right? All we said so far is that our domain is represented by the variable t. It's between 0 and 20, and it includes 0 and 20. What kind of number is it? Is it an integer? Is it a fraction? Is it positive values only? What is it? Well, like we've said before, it's a real number. Here's how you communicate that t is a real number. You write t, and you write this funny looking e. This is the Greek letter epsilon. Okay, this Greek letter here, this is called epsilon. It's a Greek letter that all mathematicians use. Okay, and then you write this. It's really a bolded R, but I just write 2 lines and then I write an R. Okay? So what this means, I know it looks a little weird, but what this means is t belongs to or is an element of, that's what epsilon means. It means is an element of. It belongs to R, which is the set of real numbers. Okay? That's the class of number that t represents. It's the class of number that t is. So let's just look at this thing as a whole. Okay? This whole phrase here means the domain is the set of values represented by the variable t such that t is between 0 and 20 and includes those values, and t is a real number. That's what this whole thing means. So like I said, this is a condensed but detailed way of explaining what kind of number t is. It's everything from 0 to 20 and all real numbers. Let's see if we can do that for range. So we set up our set brackets. We ask ourselves first what kind of variable the range is represented by. In this case, you will remember, what was it? H, right? So the range is represented by the variable h such that, now tell me the restrictions on h. What was the lowest point and the highest point? Well, h had to be bigger than or equal to 15, that was the lowest point, and less than or equal to 208. Lastly, we state the class of number that h can be. Is it a natural number? Is it a whole number? Is it an integer? Well, like we just determined previously, it's a real number. Most of the relations that you'll be doing in grade 10 math have this little tag at the end. Whatever variable you're talking about is an element of real numbers. Rarely will you run into a relation that doesn't have a real number for its variable, at least a continuous one in that regard. So this is probably the most difficult part of today's lecture. I guess I'll know that for sure later, but hopefully this makes some kind of sense, right? All this means is the set of numbers represented by h such that h is bigger than or equal to 15, less than or equal to 208, and it's all the real numbers, every possible number between 15 and 208.